The relationship here, A equals P times E raised to the RT, is the relationship for continuous growth. A represents the future value, P represents the present value, R represents the growth rate, and T represents time. We would find this particular relationship in disciplines like finance and biology and sociology and other sciences. Let's suppose that the size of a certain insect population at time t in days can be expressed as P of t, so in other words, the population at a given time, so this is just function notation, equal to 200 times e raised to the 0.08t. So we're supposed to find the population size at t equals 0. Now, t equals 0 would mean at the present, so right now. And the present value is p in this relationship here. Well, we can see that that is 200. So P of 0 is 200. But we can also see that in order to find that, we could put 0 in for t here. And then 0.08 times 0 would be 0, and e raised to the 0 power would be 1. So we can see why then this is called the present value. The growth rate. Well, the growth rate is r. So here we go. Up here in the exponent, we have the rate times the time, the growth rate times time. And here we have 0.08 times time. So the growth rate is 8%. Find the population after 10 days. So that means then that we're going to find P of 10. So in other words, plug 10 in for t. So we'd have P of 10 equal to 200 times e raised to the 0.08 times 10. So on the calculator then, we will type 200 times e. So I'm going to click second ln, and I'm going to put this in parentheses because I'm going to have a product up here, 0.08 times 10. Close that parenthesis and hit enter. And this gives me 445. I couldn't have part of an insect, so that the result then is just going to be 445. The next question says, when will the population reach 240? P of t represents the future value. So when that value reaches 240, what is the time? So I'm going to plug in 240 for the future value and solve for t. Now I see that I have my variable up in the exponent, so I'm probably going to have to use a log in order to solve this. But first I need to get this 200 away from the e if I'm going to do that. So we'll divide both sides by 200, and we'll wind up with 1.2 on the left and e raised to the 0.08t on the right. Now we can rewrite this in its log form. We would have the natural log of 1.2 is equal to 0.08t. And we'll divide both sides by 0.08. And do this on our calculator. So we'll have the natural log of 1.2, and I'll make sure I close my parentheses now. So now I have the natural log of 1.2 divided by 0.08. And that will be 2.279. Now remember, in this problem, time was in days. The next question says, when will the population double? When the population doubles, this particular expression here would be equal to 400 because we start with 200. So we would have 400 equals 200 times e raised to the 0.08t. And we're pretty much going to proceed in the same way. We'll divide both sides by 200, and we'll have 2 over here. So 2 equals e raised to the 0.08t. We will rewrite this in its log form. The natural log of 2 is equal to 0.08t. Divide both sides by 0.08. And we're going to find that t is equal to the natural log of 2, close the parenthesis, divided by 0.08. And that value will be 8.664. Days.